Electrical and Electronics Engineering Department, K.S. Ragasamy College of Technology. So this session I'm going to cover the subject signals and system. So the course code is 50EE604, digital processing. So first slide I'm going to explain about what is signal processing. So we know that there are several types of signals are there. So from that we understand that the basic signals are human, are the most advanced signal processor. Speech and pattern recognition, speech synthesis are example of the signal processor. So we encounter many types of signals in various applications. Electrical signals. So normally we studied about voltage, current, and magnetic waves and electrical field. The mechanical signals, velocity, force, displacement, acceleration, etc. In acoustic signals, sound, vibrations, etc. Other signals are pressure, temperature. So what are the measuring informations are covering into the other signals. So most real world signals are analog. So normally we see from the digital analog clocks, then all the meters. So everything in the digital analog only. So they are continuous in time and amplitude. So convert voltage or current using sensors and transducers. So these are the real world signals or analog value. So once the analog circuit process these signals using resistor, capacitor, inductors, and amplifiers. So these are the four parameters or very basic parameters to convert the signal from one state to other states. Then analog signal processing examples are audio processing in FM radios and video processing in traditional TV sets. So these are the type of analog signals are available in today. Then limitation of analog signal processing. So we are facing some of the disadvantages or limitation in the analog signal problem. Example, accuracy limitations due to component tolerance and undesired nonlinearities. So component tolerance means so each and every component, so there in a design itself there must be some tolerance value, either a plus or minus of 1 or 2%. So these tolerance value will be the reason for the limitation of accuracy and undesired nonlinearities. So there is a problem in the nonlinearity. So in our situation, we expect linear problem, but in the case we may exhibit the nonlinearity. The limited repeatability due to tolerances, changes in environmental conditions, changes in environmental conditions, examples to temperature and vibrations. Sensitivity to electrical noise. So this is the problem. The limited dynamic range for voltage and current, the inflexibility to changes, difficulty of implementing certain operations, nonlinear operations or time varying operations, then difficulty of storing informations. So the analog signal processing, the major problem is to store the data. So these are the problems we are facing in the analog signal processing. So that we go to the digital signal processing. So digital signal processing means so represent the signals with a sequence of numbers. So we are going to represent the signals in terms of numbers. So for that we are using sampling. So sampling means so we are having a multiples of data. So we are going to take out of 10 or 100 or 50 for a single sample. So we are going to pick one data from out of 10 or out of 50. So that is called a sample or analog to digital conversion. So in analog to digital conversion, so we are having a certain setup. So in this setup, so how we are going to convert this analog signal into digital platform. So perform processing on these numbers with the digital processor, reconstruct analog signal from processor numbers. So we can able to convert analog data into digital data. After the requirement, so we can convert into digital data into analog data. So analog input to analog output, that is digital recording of music. Analog input to digital output, touch tone phone dialing, then digital input to analog input. Example is text to speech, digital input to digital output, compression of file on a computer. So these are the different examples from analog to digital conversion. So what are the advantages and disadvantages of digital signal processing? So accuracy can be controlled by choosing the word length. So in an analog processor, we are having a limitation due to the tolerance. We are having the accuracy issue, but here the accuracy can be controlled by choosing the word length. In a repeatable, sensitivity to electrical noise is minimal. So in that analog issue, so we are having the sensitivity problem, but here it will be eliminated because of we are going to eliminating the noise. Then dynamic range can be controlled using floating point numbers. Flexibility can be achieved with the software implementation. Nonlinear and time varying operation are easier to implement. Digital storage is cheap. The digital informations can be encrypted but for security. Price or performance and reduced time to market. So these are the advantages for digital signal processing. Then disadvantages is sampling causes loss of information. So either we are going to take a sample value out of 10 or 50 numbers. So there is a possibility to loss of data. It is also be happening in the digital signal processing. But the A to D and D to E requires mixed signal hardware. So limited speed of processor, quantization and round of errors will be there in the disadvantages of digital signal processing. Then how we convert the analog to digital from the system. So we are having analog system. So normally it is represented by continuous time signal and the system. So after that we are going to change the interface system. So that is analog to digital converter. Then it converts to the digital platform. It is a discrete time signal and the system. The number sequence is either 0 or 1 pattern only. Again we want to convert into digital to analog system means, so we have digital to analog converter. So the same sequence will be converted into analog platform. So this is the processing method of A to D. So for digital signal processing, so how we are giving input, how we are getting the same output. So what are the things happening in between the processor. So first we are giving analog input to the analog filter. So analog filter, we are using aliasing filter to avoid aliasing for sampling. Then band limited signals given into the A to D ADC. So ADC means analog to digital converter. Then we are giving digital signal to digital signal processor. Either it may be a computer or microprocessor or microcontroller. Then it will be given to the processor signal given to the digital signal processor. Again it is given to the DAC digital to analog converter. Then it is given to the output signal. Then reconstruction of the filter in order to avoid aliasing for sampling effect. Then the same analog output will be given to the system. So in the digital signal processor, we are having certain sequences for ideal A to D converter and DA converter. So first thing we have the given the continuous time signal x of t to anti-aliasing filter. Then it converts into the filtering the noise signals and given to the sample and hold circuit. So the given input is xa of t. So sample and hold circuit hold the sample for the particular time. Then it will process the signal. Then fs is nothing but 1 by t. Then it will given to the analog to digital converter. The sampling frequency is nothing but 1 by t. Then after that it will given to the discrete time system. The same sequence will be reversed again. D to A converter, sampling frequency, then sample and hold circuit, then reconstruction of the filter, then the corresponding YT of T will be output part. So thank you for listening.